Welcome back. So happy Pongal, and today was a festival, so I had to go out to a temple, and then we went for a movie, due to which I was not able to solve the problem early, but still there's time left, and let's get back to it. Okay, so today's problem is number of good paths. Oh, wow, I've already done it. I've liked it and I've even added it to my list. So this really must be a really good question. Oh, I guess I remember doing this in some contest. Okay. Nevertheless, let's read the question. So we are given a tree, and we are each and every node is given a value, and then we have an edge list. Okay. A good path is a simple path that satisfies the following conditions. The starting node and the ending node should have the same value, and all the nodes between the starting node and the ending node should have values less than or equal to the starting node. Okay, so a path, if we have a path from here to here, that means this value and this value have to be the same, and all the elements on this path should have a value which is less than or equal to the value of the starting node. Okay, we need to return the total number of distinct good paths. Okay, and okay, so even a single node is considered as a valid path. So this is a tree, and in tree any two nodes would have how many paths? So if I have, let's say, two nodes, can there be more than one path? Let's think about it. So this is a tree, so for this to be had to have another path, this has to be connected in a different way, but then this would create a cycle. I think it is not possible, I guess. So not I guess, I'm sure. So in a tree, for any two nodes there has to be a single path. So I think this then this boils down our problem to mm, uh, find the total number of nodes. Okay, so yeah, so one thing we can do, the brute force would be uh, uh, f- uh, finding every node, taking every two nodes possible, and then checking if the path between them has a value greater than or equal to this, and then it won't be possible, else would count it as a good path. Its time complexity would be of n square somewhere around, but let's think of something better. Now, these guys have been giving the problem. These guys have been giving a union fine for the past few days, and then I've done this problem, fairly recently. Like September isn't that far back, so I kind of remember that this problem can be solved using union find. So that sucked the joy out of this question, because I already seem to have a hint of how to solve it. So 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 the thing is, what we can do is, so in a good path all the nodes should have value less than or equal to uh, the values of the starting and the ending node. So the trick, what we can do here is, we can start connecting the tree uh, in ascending order of the value. So let's say if I'm connecting all the nodes that have values 3, then I'm sure that none of the values none of the nodes whose values are greater than 3 are connected, because I'm going through I'm going in an ascending order, so I'm sure that all the nodes that I've connected have values less than or equal to 3. So the problem in that case would boil down to just finding the total number of nodes having the value 3 connected. I hope you're understanding what I'm trying to say. So if I if I like, I'll take union find data structure, and this is the edges, these are the edges, right? So initially I'll take the tree as a disconnected, completely disconnected graph. So all the nodes would be completely disconnected, and somehow at the end I have to form this tree from those disconnected nodes. Okay, so these are the connections. So how am I going to connect? What I'll do is I'll start connecting the nodes that have the lowest values, and then I'll keep building on that. I'll keep connecting the nodes in an ascending order. So let's say now I'm connecting all the nodes that have value x. So okay, so if I'm connecting all the nodes that have values x, then I'm sure that all the connections that have already been made before are of the nodes that have value less than or equal to x. So it is not theoretically possible for me to find a path in this current graph, in this current graph, that has that has value greater than or equal to x. So all the paths that are present are good paths. So I just have to find total number of x's that are connected, and then I can do xc2, like all the, like if these x's are connected, then I can go to each connected component and then find all the x's, and then I can form path between all the two x's in each and every connected component. So that would be xc2 for each component. At each step we can do that. So what I'm trying to say is, okay, the first thing is I'm going to create a data structure. I'm going to create a new array called as values, okay, which would be like it would have, like I'm going to sort the nodes based on values, right? So that's what I'm going to do. Okay, so yeah, and I think enumerate would work here. So values would be enumerate of files. Would this work? Decency. Oh, come on. Okay, I'm getting an enumerate object. Okay, I'm just trying to play around with it. Okay, so I have all the, okay, I have the node number and its value. So first I'm going to sort it based on its value. So values dot sort lambda x to x of 1. It's funny, isn't it? So now my values are sorted, and now my values are sorted, Do I have to create an edge list, adjacency list? Yeah, why not? Adjacency equals to default depth list for x comma y in edges, adj of x dot append y, adj of y dot append x. Okay, so now I have this adjacency list. So for each value, it would be good if I have like a data structure in which I have like the keys as the values and the key as the value of the node, and uh, and the value as all the nodes that have this particular key. I think that would be more useful, don't you think? I don't know. Let me try. I don't know, I'm just being too bad at implementation. I think I've gotten slow. I haven't been doing a lot of competitive programming these days. That has hindered my speed. I used to code a lot faster. Okay. Okay, so now we have this. So we'll go in the order of the sorted nodes. First, I need to have union find data structure. I'm not going to type all that again. I'm just going to copy it from somewhere. Union find. Where is union find? Well, I could have copied yesterday's code, but in yesterday's code I haven't implemented path compression. So I'm sure there might be some problem where I have implemented like path compression as well. Okay, this is C++. Or maybe I have it somewhere. I have it somewhere. I remember. Where in documents, learning, not here. By this time I would have like implemented the whole union find. Okay, somewhere here, union find. Yeah. What? I just copied it. No. We have the union find data structure here, and let's go. let me have an answer. And I don't know, my brain is not working right now. I'm just having fun. I know this video is ruined already. Okay. Okay, so I'm going in a sorted order. I don't know what I'm doing. I'm just going to not speak and just code now. I think you'll understand my code. Okay, so they are connected now. And now I got to find okay, now I can what I have to do is so now I've connected the graph and now I have to find like for each connected component I have to find total number of even if I'm running like let me create a like leaders graph leaders and for okay now I have it now. NC2, what is the formula of NC2? N into n minus 1 by 2 and n plus 1 by 2 n into n minus 1 by 2. I don't know if this is work. This is not probably not going to work. Well, I'm not sure what I've written. Okay. Like, a single nodes can be considered as valid path, right? Okay. What? I mean, I was really scared. I thought it was going to time limit. So yeah, congratulations to myself on 200 days streak. And let's get. I know. I've been sloppy in my implementation. Let me once go through the code. Let me once go through the concept once. Tayasuki. See, so what I'm thinking is, first I'll consider all the nodes to be completely disconnected, okay? And then what I'm going to do is, I'm going to I'm going to start connecting these nodes. One second. I'm going to start connecting these nodes so as to get the original tree, and I'm going to do so in an increasing order of the values. So like I'll first connect uh, all the edges that have the smallest value, and then I'll go on to the next smallest value, and then I'll go to the next smallest value. I'll keep on doing that. Still I get my original graph back. So why am I doing that? The reason is that if I go on in this order, then when I'm connecting, let's say, these two nodes, I'm 100% sure that there are no paths in this current graph that have values greater than the value of either of these paths, right? So all the paths that I have are good paths, right? So now my problem boils down to, uh, we have to find a total like all the instances of value which are connected, right? You get it? So then what can we do? We can just we'll have a union finder data structure. We'll keep on connecting the nodes, and after connecting nodes of each value, what we can do is we can see the total connected components. Like in this connected components, there are x values that have value x nodes that have value k, and then we have here x values y values that have value k, and here we have z nodes that have value k. So we can connect all these paths with all of these. Like we can connect any two nodes in this, then they would form paths which have starting and ending point as value k, and all the paths in between would have value less than or equal to k, because that's the order we are going in. So that would be x into nc2, so that would be x into x minus 1 by 2. that will do for each and every connected component. So that's what I have done here. So I have this union find data structure, and then I took this dictionary of nodes, and I've put, like, for each value I've created a map in which the keys would be like these values, and the values would be uh, all the nodes that have a current particular value. And then I've created the adjacency list out of this edge list, and then I have this union find data structure, and then I'm going in this sorted fashion, and then I'm connecting the nodes, and then I'm finding all the connected components, and then for each connected component I'm adding NC to the answer and returning the answer. And as, like, single nodes are considered as valid paths, I'm adding all single nodes because they are valid paths. So that's what I've done here. So yeah, that's it. See you tomorrow. Bye.